to get the business owner had an average goal at the average length of customer stays above 10 minutes. Is there evidence in this confidence interval that the business has met this goal? Okay, so they want more than 10 minutes. So, is 10 minutes within our parameter? Yeah. So we have to say no. We have to say no in this case because of the 9.4 minutes. Okay? So if their goal is to say, hey, we want this 10 minutes to take place within our margin of error, being that we go from 9.4 minutes to 13.6, so think about 9.4, so let's say this is like 10 minutes right here. Being that that's within this, we can't say, because it is possible that somebody spent less than 10 minutes. We are 80% confident that we're going to get people that fall into that. Okay? So a lot of times it kind of seems a little obscure going, well, it's in there, but I can't really accept it. All right, so let's get ourselves in trouble. It says, assume the Surgeon General has a goal set that less than 15% of Americans, so less than 15% of Americans would smoke. Uh-oh. They have a 99% confidence interval. Okay? So they're fairly certain that their information is going to fall in between this. These are both percent, sorry. Okay? 99% confidence interval, you're pretty certain you're going to capture your audience. Find the point in the estimate and explain its context. So the point estimate is the middle of this. So the easier way to do this, and of course if you have a calculator, it's real easy. So that's 9, that's 14, 34, divide that by 2, 17.45. So 17.45, this is our point estimate. Okay, so that's the answer. And then, so it basically says our best estimate on this study is that 17.45% of people smoke. Okay? So, when they say that's the point estimate, it's just right directly in the middle of our margin of error, or our confidence interval. So, yeah, baby. All right, so number 10 states, find the margin of error and explain the meaning and the context. Okay, so the margin of error, what it means in context. So we are 99%, number 10, we're 99% confident that our estimate of 17.45% is accurate within 1.75%. Okay, so now here is a question. Where did this 1.75% come from? Yeah, so I found this. This was halfway in between these two. So 17.45 is halfway between 15.7 and 19.2. How far away is 19.2 from 17.45? Well, that's 1.75. How far away is 17.45 from 15.7? It's 1.75. So we have a little tiny bit of wiggle room here, which is okay. Number 11, Number 11 says interpret the confidence interval in the above context. So we are 99% confident that between 15.7% and 19.2% of Americans smoke. Okay? Whether that's a good or a bad thing, I'm not, trying to give any reasoning why you should or shouldn't smoke. I say there's probably data that says it's bad for you, but but I can tell you in the 1960s, the Surgeon General would come on TV and say flat out, after a big meal, why don't you enjoy a Winston? Which Winston's a brand of cigarettes. So Winston paid the Surgeon General big money to go on national television to say on a commercial that after a large meal, go ahead and have a Winston.
Awesome.
Yeah.
Go facts though. He was making insane.
I was safe though. I was born in 1970, so it should be fine. All right. Is there evidence that this confidence interval that the Surgeon General's goal has been met? So is there evidence that this confidence interval that the Surgeon General goal has been met? Explain. Okay, so we have to say this is no. The entire interval would need to be below the 15.2%. Okay, the 15.2% is, wait, I lost something someplace. Where's, below 15%. I'm sorry, 15%. 15% was the original in the context. They want to go of less than 15%, but because our confidence interval goes between 15.7 and 19.2, 15% is over on this side of it, so we can't say that the Surgeon General wants it to happen. Okay? Based on this study. Number 13 says a local realty office conducts a random sample of 100 local homes to determine the average property value within the city of Denver. The resulting confidence interval, now this is made up, so we know it's more than this. The confidence interval is between point of estimate is $440,000. Okay? And then you have a margin of error of 30,000. So if I wanted to set up my confidence interval, we'll call CI, we're going to go 440 minus 30,000, so I get to 410,000. And then I'm going to add 30 to 440, so 470,000. Okay, so we are confident that the average property value in Denver is between $410,000 and $470,000. Okay, and again, this is from a couple of years ago, so this is not accurate, but it still satisfies what we're saying. Is there evidence in this interval to support the following statement? Most homes in Denver, sell for between $410,000 and $470,000. Okay, so we're saying that this is our confidence interval. Explain. And it says the interval attempts to capture the overall average So no, so we have to say no to this. The interval only attempts to capture the overall average. It's trying to capture overall average. Okay, so a couple of things that also stick out is we have a confidence interval, but do we have a percent that we go with it? Are we 95% that we're going to fall within this? Are we 99%? Are we 30%? It doesn't tell us any of that. So that's another marker for us to be concerned about. Number 15, name a way that the researcher could have conducted a study that would have resulted in a smaller margin of error. You increase your confidence interval. Okay? Rather than going from 410 to 470, maybe you take it to 0 and 500,000 or something. Okay? So if you just increase it, so this margin of error has to increase. So increased margin of error is, another way to think about it. Okay? And then 16, last one, and we'll get to our lesson. A writer claims that the average home sale price is $425,000. Is there evidence in this confidence interval to dispute the claim? So does 425 fall within here? So 425 is within the interval. And is considered plausible. So that is the ins and outs of what that homework work would have been. Okay, can we go to 5.7 notes? We're good to go? 5.7, so it looks like page 14 is where I'm at. Okay, so one proportion z interval. So we'll only do one proportion, just to let you know there is a two proportion z interval as well. You will save that for a different year that you can take statistics. So in inferential statistics, a sample is used to estimate the population parameter. In this assignment, we will incorporate a margin of error into this estimate. So this is just a hypothetical. Consider candidate Jones, who's running for mayor of South Bend, Indiana. The following excerpt of a news article about the election. It says, according to a recent polling, candidate Jones has 54% supporting and has a margin of error of 4%. Okay? So that means we can create our confidence interval by going 54% minus 4%, so 50%. 54 plus 4% is 58%. Okay, so the margin of error is a way of estimating the likely maximum and minimum of the population parameter. In this case, the actual amount of support for Jones in the population. If we conclude the margin of error is plus or minus 4%, the current estimate of 54%, we would obtain the interval from 51. Yes, from 51 to 57. I think that's an error. That 57 should be a 58. Okay, the singular estimate of 54% is the point estimate. Okay, so that's what we're trying to target. The estimate is the single best estimate we have of the population parameter. So remember, we don't always find a parameter. That's just what we're trying to get towards. In other words, if we had a single percentage, our best guess is the actual support for candidate Jones enjoys would be a 54%, even though we have the the interval that expands that. The idea that candidate Jones likely enjoys anywhere from 51 to, it should be 58%. I don't know why that's just an error. So that should be 58%. It's called an interval estimate or confidence interval. This estimate in many ways is more powerful than a point estimate. If candidate wanted evidence that the level of support was over 50%, the interval estimate provides, after all, the entire interval that's greater than 50%.
But it's not. Does that change anything to the actual interval within 58%? Does that change it?
So I don't know why he has errors in here. Maybe he had it at 3% originally. There's not a 3% in there. I'm seeing a plus or minus 4, right? Yeah, so this right here, so we're basically saying, is he happy about this? Well, if you were to say the 50%, is he happy that he has 50% of the vote? Well, hopefully there's a third candidate in there. If he's getting 50% of the vote and the other 50% of the vote's going towards the other two candidates, looks like this person could be winning their election. Okay, so the margin of error for an estimate of a population proportion is provided within the following formula. Okay, so margin of error, MOE, is equal to Z, and then they have like this star, root P 1 minus P over N. So this is the equation they're given. So the first question might be, what is Z? Okay, yeah, what is Z? This variable is often referred to as a critical value. So Z is just another term for a standard deviation. A standard deviation doesn't have to be a whole number. It could be a decimal. So that's what your Z value is. So we're trying to figure out what our Z value is. So it's all going with the normal curve. The variable is often referred to as a critical value, is what the standard deviations from the mean in both directions would need to capture, a predicted percentage range, or the bell curve. So our bell curve, in a normal situation, you would have 68% of the population falls within one standard deviation, 95 that falls within 2 standard deviations, and within 3 standard deviations, and this is keeping it normal, just a simple rule, would be 99.7. If we wish to capture 68% of the bell curve, we need to move 1 standard deviation away from the mean. So 68% of the bell curve, our z-score. So if we were trying to capture the 68% of our population, this is 1 standard deviation on our normal curve. So that means our z-score, our z-star, would be 1. Okay? Now there's other things that would allow us to find different z-scores, but that's what's taking place here. If we wish to capture 95% of the bell curve, we would need to move 2 standard deviations. So if I wanted 2 standard deviations, my z-star would equal 2, because this is talking about the standard deviation as far as the normal curve. Okay, you doing okay?
So what do you do if it doesn't fall on
Thank you for asking. We're on to page 15. A handy shortcut for finding the z-star value of any fixed percentage is followed by the following calculator command. Okay, inverse norm. Okay, and Mr. Anderson calls this halfway to 100. Okay, so that is, to capture the middle 84% of the bell curve, you need to do the inverse norm of 0.92. Okay, so if we were to do the inverse norm of this halfway, if we wanted to capture 84% of the population, okay, so how far is 84 from 100%? 16. What's half of 16? 8. Okay, so what I'm going to do is, if I wanted to capture the middle 84% of the population, so you're talking on your normal curve, you want this to be 84% of your population, which is not a number that falls into our normal distribution. So we want to figure out what these numbers are. So the reason we go halfway there is there is basically 8% of the population over here and 8% over here in a normal curve, because if I add 8%, 84%, and 8%, I get to the 100%. So the reason why we're saying we're going halfway to 100 is if the entire thing is 100%, in order to eliminate a bottom score or a top score, that 8% or whatever it might be, we're going to take the 16%, which is how far we are from 100, divide it in half, and we're going to get to 8%. Okay? So if we do the inverse norm on the calculator, and it's done for us, but it's in the same place on our calculator where to find it. You would just plug this in, and it would come out to 1.405. Okay, so that means this is 1.405 standard deviations away from the mean, and this is 1.405 standard deviations away from the mean. Okay, rather than one whole standard deviation. So we have that z-score. So if we wanted to find the margin of error at 90%, if we wanted to find the margin of error at 90%, what we would do is we're going to go the z star root p minus 1 minus p over n. And so we have to do the inverse norm. Oops. And again, it's a calculator command, and I could show you later how to find it. We've done it before. Okay, so 90% is how far away from 100? 10. 10 divided by 2 is 5. So we're going to do the inverse norm of 0.95 times, and then they said a random sample of 60 people shows 75% support cutting property taxes. So I have 0.75 here. I have 1 minus 0.75 here. And that's all divided by the 60 people we sampled. So if you found the inverse norm on the calculator, it's going to give you a certain z-score. And so I'll just find that real quick so we have it. Here. Second distribution, inverse norm 95. Paste. All right, so this number here, when you do it on a calculator, comes to 1.645 times the square root of 0.75 times 1 minus 0.75 is 0.25 over 60. And if you went and did the math, you're looking at 9.9% of your so the margin of error is 9.9. Find the margin of error. So our margin of error is 9.9%. So interpret that on a 90% interval, confidence interval. Okay, so we know that they said that 75% support. So I'm going to go plus or minus 9.9%. So this is going to find us, if we go 75 minus 9.9, we get 65.1%. And if we go 9.9 plus 75, we get 84.9%. So this means that we are 90% confident that if we did another sample of people, that are people who support some sort of tax cuts for property taxes would fall somewhere between 65.1% and 84.9%. Okay, it says we are 90, and I said it, and it looks like I said the right thing. Okay. All right, and then B, we have to, example 2, we'll have to work out. Okay, so I want to do this just so you can have your eyes on the inverse norm. Let's load that. Yay. Yeah, baby. All right, clear that out. All right, so it says a random sample of 200 Cherry Creek High School students. So we have 200 people that we're surveying. was conducted. 36 people plan to attend the next theater event. 36 people want to attend the next theater event. Okay? So we wish to estimate the true percentage of Cherry Creek students who plan to attend the event. So, one, are we confident that there's more than 200 people at Cherry Creek High School? The answer is yes. So now we want to figure out, we sampled 200 people randomly, whether it was based on student number and we, random number generator or spit it out or whatever. We find that 36 people of the 200 people surveyed said they're going to attend the next theater event. So we want to know really how many people in Cherry Creek High School. Find the margin of error of 99%. Okay? So how far is 99% from 100?
1%.
1%. Halfway, or 1% divided by 2 is 0.5. Okay? So I'm going to do an inverse norm of 0.995. And if I do that on the calculator, this is where it lives. I go second, vars. I do an inverse norm. I want the area to be 0.95. Paste. Enter. So we're looking at 1.65 rounded up. So that means that what does that mean? Find z-score. And then I'm going to go 1.65, which is our z-score, z-star. And then we're going to go root. And then, how am I going to do that? It's going to be 36 divided by 200. You need to find a percent. 36 divided by 200 is 0.18. 1 minus 0.18 is 0.82 divided by our 200. So I'm going to go 0.18 times 0.82 divided by 200. Take the square root of that. So we're going to get to 0.03. Oh, I forgot to multiply by 0.5. 1.65, 1.65, sorry. That comes out to 0.05. So, how confident are we? We should be good. So, friends, I know we're about done. Would you? What did I just teach? 5, 6? So let's have us try. Page 79 and 80. Give it a good try. Sound like a deal?